5, 4, 3, 2. Main engine start. 1, 0. And liftoff of the Delta II with the NPP satellite, blazing the way a new technology for climate research and weather forecasting.
Chamber pressure in the main engine, good chamber pressure in the 2 diverniers, and good chamber pressure in all 6 groundlet motors. Passing 24 seconds into the flight. Pressure beginning to trail off a little on the groundlet solids as expected.
Good morning, everyone. This is our post-launch news conference for the Delta II with NPP, and here to discuss our activities for the launch and the mission is Ken Schweer, the NPP project manager from NASA's Goddard Space Flight Center, Jim Gleason, the NPP project scientist from NASA's Goddard Space Flight Center, Michael Freilich, the director of the Earth Science Division at NASA headquarters, Chuck Gay, the acting associate administrator of the Science Mission Directorate at NASA headquarters, and Mary Glacken, the Deputy Undersecretary for Operations for NOAA, the National Oceanic and Atmospheric Administration. And we'll begin first to talk about the NPP spacecraft with Ken Schweer. Ken?
Thank you, George. Let me first start off by saying yesterday evening when the tower rolled back and my team got to go out and look at the Delta II one last time, beautiful sunset, lights on her, probably the most perfect weather that you could have at Vandenberg, was a majestic sight. We didn't want to leave. Of course, we know she had to leave soon, but we hung around as long as we could, and we truly appreciated that opportunity. Shortly after we separated, just a few minutes, we already had acquired the TDRS communication satellites, and our telemetry, our systems were looking good. The very nervous time and where you keep your fingers crossed for the solar ray deploy so you could be power positive went extremely well a couple minutes later. We could see the batteries charging. All the telemetry was looking nominal. We were anxious to have our first contact over Svalbard, Norway. That went very well. All the systems look strong. Communications look strong. Since then, I just received reports that we have been commanding through the TDRS satellites. So my stellar mission operations team back in Suitland, Maryland at NOAA Satellite Operations Facility is doing the great job I knew they would. Talked to a few folks who were at the viewing site. They said the sky was absolutely gorgeous. They could see forever, but the launch was even much better. On behalf of my entire team, I truly want to thank the KSC and ULA team for just an amazing partnership, an amazing ride. Couldn't get better. Put us exactly where we wanted to be. Was smooth. And now the future of NPP starts, and we look forward to NPP touching the rest of the world. Thank you. George?
Thank you, Ken. And now to Jim Gleason, the NPP project scientist from NASA's Goddard Space Flight Center. Jim.
Thank you, George. One of the great pleasures of being the NPP project scientist is interacting with a large and diverse number of scientists who are going to be using the NPP data. And uniformly, whenever I work with these groups, land scientists, ocean scientists, people doing weather research, forecasters, people who want to use the data for their application, whether it's fires or air quality, are always uniformly really expected and asking, when are we going to launch? I can't wait to use the data. So now that we've had a successful launch and the data will start flowing, I know we're going to have thousands of users around the world who are anxiously waiting to use NPP data for more applications than I can even think of. So thank you, Ken, for your wonderful engineering team, and thank you for once again to echo Ken's for the KSC and the ULA for giving us an absolutely perfect launch. So thanks to everyone, and thank you, George.
Thank you, Jim. And now to Michael Freilich, the director of the Earth Science Division at NASA headquarters. Michael.
Thanks, George. It's an unadulterated pleasure to be talking with you now today at the start of the NPP Science and Operations mission. It occurs to me that NPP could actually stand for the National Polar Orbiting Partnership. National, not just because multiple agencies contributed money and intellectual contributions to developing the spacecraft and the ground system, but national because the measurements from NPP will be affecting everyone in this nation and indeed perhaps in the world. NASA research, NOAA weather forecasts, and a whole variety of applications, as Jim Gleason mentioned earlier. Polar Orbiter goes without saying, and I too would like to add my thanks and our thanks to the KSC and ULA teams that gave us such a wonderful ride on the Delta II rocket. But most important perhaps is that final P, the one that stands for partnership. Not only a partnership between NASA and NOAA and DoD in the design and implementation of this mission, but partnerships between government and industry, as always, for our space missions, and partnerships between scientists and engineers to take the grand ideas and designs that the science community had and to actually turn it into a realistic mission. And I, too, would like to pay particular kudos and recognize the contributions that Ken Schwer made in establishing and guiding cohesive teams in all aspects of NPP. Ken's teams kept their eyes on the objectives throughout and have delivered for us this remarkable mission right now. And Ken, your courage and your wisdom and your guidance was simply invaluable for this mission. So we look forward to many, many years of great advancements of science and improvements of forecasts from the NPP mission. George?
Thank you, Michael. Next, Chuck Yeh, the Acting Associate Administrator of the Science Mission Directorate at NASA headquarters. Chuck.
Thank you, George. You know, the launch of the NPP spacecraft is not only an important accomplishment for NASA and NOAA, it also represents a significant benefit to the nation. The next generation instruments that are being proven on NPP will lead to better weather forecasts and improved scientific understanding of our planet. On behalf of NASA, I'd like to thank the incredibly talented team that has made NPP possible. The project team at Goddard, led by Ken Schwer, the instrument providers, Northrop Grumman, ITT, Raytheon, Ball Aerospace, spacecraft provider Ball Aerospace as well, and the jointly developed ground system led by NOAA, NASA, and Raytheon, and certainly the ULA team who gave us another great ride. Nice job, everyone. George?
Thank you, Chuck. Next to Mary Glacken, the Deputy Undersecretary for Operations for NOAA. Mary?
Thank you, George. I joined my colleagues today with being really thrilled. It was a thrill to watch the bird go up this morning in the beautiful, clear night sky with the stars out there and all. But I think it's even more thrilling to know what it means for the nation. NOAA's been using environmental satellites for more than 50 years, and we use them to monitor and forecast extreme weather events, and NPP is going to play a significant role in that regard. These forecasts allow us to warn people to get out of harm's way and allow us to plan and businesses to make important decisions in their operations. The spacecraft is going to provide us many valuable essential data, including cloud, vegetation cover, ocean color, sea and land surface temperatures as it flies pole to pole. I'd also like to echo my colleagues' thoughts about partnership. It's been a lot of years that NOAA, NASA, Air Force, and industry have worked together, and I think it shows a real value for the nation when we're able to do this. NPP is a NASA satellite, and NOAA and Air Force provided the key instruments that collect data for weather forecasts. It has a real value to the nation. It's going to help us do many things beyond weather, including tracking ash plumes for volcanic eruptions, helping emergency responders fight wildfires, and measure Arctic sea ice and changes in the ozone level. I mentioned before that it's going to be used operationally. NPP is going to replace our operational NOAA 19 satellite. It's a bridge between our existing polar orbiting satellites that NOAA operates and our next generation of satellites known as the Joint Polar Satellite System, or as we call it, JPSS. The first JPSS-1 satellite is going to be launched sometime in 2017. The launch of NPP is one of the many steps that NOAA is taking to make America a more weather-ready nation, a nation that can better plan for extreme events like the ones we've experienced this year. It really represents an investment in our future and in being able to prepare for that. Thank you, George.
All right, thank you, Mary. And given the hour that it is here, we have no media in the audience. There are none with online questions and none at the other NASA centers. It's been an all-nighter. So with that, we will close the briefing, and we have some more video to show you of the launch that everyone is so pleased has gone so well, both from the Delta II and for NPP. So thank you, and that concludes our coverage for the NPP launch. Green board, T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Main engine start, 1, 0, and liftoff of the Delta II with the NPP satellite, blazing the way a new technology for climate research and weather forecasting.
Chamber pressure in the main engine, good chamber pressure in the 3 corrections, the 2 diverniers, and good chamber pressure in all 6 ground-lit motors. Passing 24 seconds into the flight. Pressure beginning to trail off a little on the